and welcome to Arch Education video on Further Maths of Edexcel course. And chapter 1 in the Edexcel book is complex numbers in the first year's book. So what is complex number, first of all? And the easiest thing which comes to mind is complex numbers are the numbers which are not real. And all the numbers you have dealt with in GCSEs and in normal maths till now are the real numbers. So numbers which are not real are complex numbers. And they're written in the form of a plus b I. Okay, I'm going to explain this to you what it actually means. And in MEI, some books use a plus b j instead of I, but that's all right. Okay, we're going to work on adding, subtracting, multiplying complex numbers first of all, and these are the questions. But I would probably first of all do for you these two questions. Solving quadratic equations, you've learned that in GCSE, you learned that in normal maths. Okay, if I was to solve this quadratic equation, many methods, obviously your calculator will do that for you as well, but let's do one method which I think is very powerful, is completing the square. Okay, and you got x plus 1 squared plus 4 equals 0, and x plus 1 squared equals minus 4, and you get stuck in this. You cannot solve this equation anymore because square root of negative number is not allowed. You would have written x equals plus and minus square root of negative 4, which is not allowed in the real number system. That is where mathematicians devised a new system called complex numbers. And the reason for learning complex number in the simplest way is that solving quadratic equations which we did not solve in the previous knowledge we had. Right, so I'll come back. You're going to do this question yourself as well, guys. So over here then, I want to write this as square root of 4 times square root of negative 1. We've learned from our indices and the surds in normal maths that for multiplication, the surds are, you can split them. So the answer here becomes, and this negative 1 square root is that the complex number which comes in, this is called the iota or j. So x plus 1 is equal to 2 plus minus 2i. So x equals minus 1 plus minus 2i, the two roots of this equation. Okay, and that's where the need of complex number, the need for learning complex number comes in. Thank you. I want to nice look at these questions, that how do we multiply, divide, multiply and add and subtract complex numbers first, then we'll come to division in a minute. And this is simply like normal algebra, like normal brackets. Okay, I'm going to give you a chance to do this, expand the notation, then we see how do we solve this. Okay, pause the video for a minute and try and expand the brackets for me. Right, so when you multiply out the brackets, you get to this stage. What do we do now from here, people? This is where I come back to definition. This part which doesn't have that I or j thing is called the real part of this, and the part with I or j is called the imaginary part or the complex part of this. The whole thing becomes a complex number. What we need to do here, people, you have to add or take away, like in algebra, the real parts together gives you 24, and add or take away the imaginary parts together. So this is plus 7i. So you can relate this to your adding or subtracting like terms. Similarly, you have to multiply this bracket like we normally do in algebra, and we reach here. Same thing again, I do 4, but before I do that, you need to make sure, as a side work over here, I'll teach you this. Whereas the iota is square root of negative 1. So iota square would be square root and square of that. Square and square root cancel each other, that would be negative 1. So iota cube would be iota square times iota, which is minus iota, because iota square is negative 1. And iota to the power 4 is equal to minus 1, which is iota square, is a square, and the answer is 1. So you can see iota, the complex part, the imaginary part of the complex number, actually if you raise it to power 4, it becomes 1. So that means you can relate to further. Iota 5 would be 1 times iota, which is just iota, and so on and so forth. So for using that, this one becomes minus 1, and this becomes 4 minus 81 is minus 77, because that becomes 81 minus 81 times minus 1 is minus 81, and minus 36 iota. So that's why that's how we multiply two complex numbers. And over here, iota, this becomes 60 iota cubed, which further gives me as minus iota. So minus 60 iota is the simplest way of writing these numbers. Lovely. The work we've done up to here goes up to exercise 1A, 1B, and 1C of the Edexcel book, which is by Pearson's, the green colored book 1 is. Right, we move on to the next stage, conjugate of complex numbers, and I would advise you to relate conjugate of complex numbers like conjugate of the surds in GCSE or in normal maths. So 3 plus 4 iota, its conjugate would be 3 minus 4 iota. So 3 minus 4 iota, its conjugate is 3 plus 4 iota. And minus 4 plus iota, the conjugate is minus 4 minus iota. So what do? You just end up changing the sign of imaginary part, and that becomes the conjugate. And where is this conjugate help us in this? Is the dividing by complex numbers. We've done adding, subtracting, multiplying above, so we're going to do dividing by complex number over here. Absolutely relate that to the surds. We do what? We times and divide by the conjugate of this complex number. Okay, you've just learned how do we multiply the complex numbers. So would you do this multiplication yourself? I'll pause the video for a minute, then we see where do we get from there. Okay, so this is where we reach. And now what do? From a previous knowledge, we learned up there, this iota square should turn into times by minus 1. And here, that's the beauty, guys. Have a look carefully. Negative 3 iota crosses out with positive 3 iota. They cancel each other. And this turns out to be negative times by negative 1. So final answer is 15 times by minus 1 is minus 15. 3 minus 15 is minus 12. And minus 14i. At the bottom, this is 1 minus 9 times 1 is plus 9, so over 10. So this is the beauty of conjugate of complex numbers. It helps me divide, and the denominator is a real number. Relate this to surds once again. We do rationalize the denominator. That means denominator should be this number without surd, and here denominator is number without that iota thing. Okay, you can write simplified in a plus iota b form would be minus 12 over 10 and minus 14 over 10 iota. Obviously, you can simplify the fractions thereon. All right, now we attempt question number 4 on exercise 1D. It says z equals this complex number, and we're going to find the value of z plus 4 divided by z minus 3. Step 1, we put z in place and simplify to see what the complex number is. And we get 8 minus iota root 2 over 1 minus iota root 2. So this is now same as this question. Dividing is something by a complex number. In this case, in both the cases, we have dividing a complex number by a complex number. What do? We rationalize, similar like rationalizing the denominators. We times and divide by conjugate of the complex number denominator. Okay, do that. Let's see where do we reach from there. Okay, and we reach here where we have 8 plus 8 root 2 iota minus root 2 iota plus 2 iota square. Then this at the bottom, and knowing with our knowledge of iota squares, and we simplify this further to get the following answer. And finally, we reach to this stage, which I think is correct. Hopefully, you can check iota square has been changed into minus 1, and we simplified and cancel these two terms. Right, guys, in our next video, we will be talking about how do we use complex numbers in solving quadratic, cubic, and quartic equations, or how do we write the equation when roots are given. Good luck, happy learning.